Hello students, welcome to those classes once again. Today I am going to discuss the Coulomb's law with the gravitation law. Let us see how we can compare and what new physical quantity we are going to discuss now. Okay, so here I have penned down here comparison of Coulomb's law with gravitation law. Okay, what is Coulomb's law? I had already explained you Coulomb's law. The force of interaction between two point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay. So in mathematical form I can write Coulomb's law as Fe. It means electric force 1 upon 4 pi epsilon naught Q1 Q2 upon R square. That is Coulomb's law in mathematical form. We have also studied the gravitation law. It has been put forward by the Newton. Newton said that every celestial body attracts other celestial body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Actually, this is the force of attraction only, and mathematically we can express the universal law of gravitation by the relation. Let's see what is the relation. Fg capital G m1 m2 upon r square, that is the gravitational law. That is the gravitational force, or that is the force exerted by one celestial body on another celestial body. If one body is earth, then this is known as a gravitational force. Okay, mathematically I write down here Fg is equal to capital G m1 m2 upon r square. Okay, here 1 upon 4 pi epsilon 0, that is the proportionality constant, and this proportionality constant k is equal to 1 upon 4 pi epsilon naught. Its numerical value is 9 into 10 to the power 9 Newton meter square Coulomb to the power minus 2. Similarly, what is G here? G is the universal gravitational constant, and the value of universal gravitational constant is 6.67 into 10 to the power minus 11 Newton per meter square kilogram to the power minus 2. Now, we are going to discuss we are going to compare these two forces. Let's see. First comparison. Actually, the gravitational force is of attraction only. And gravitation force, this is the force in which the two bodies attract each other. So that is the force of attraction only. But electric force that is applied by the Coulomb, put forward by the Coulomb, electric force may be of repulsion or attraction. It means electric force, we can attract, the charged body can be attracted or they can be repelled, but in gravitational force there is always a force of attraction only. Okay, next, both the laws obey inverse square law. What is inverse square law? Actually, you have seen Fe is inversely proportional to the square of the distance between them. In the same manner, Fd, the force, gravitation force, is also is inversely proportional to the square of the distance between them. So this is the similarity. Okay. Next one, electric force is stronger than gravitational force. This is stronger than gravitational force. How much strong it is? I said it is stronger, but how much strong this force is from the force of attraction? Actually, it has been observed that is the important question for 1 mark. That question may be asked, what is the relation between electric force and gravitational force? That is F is equal to 10 to the power minus 39 Fg. You can compare how much large this force is. It means the electric force is 10 to the power 39 times the force of attraction in universal gravitational law. So you can say this force is very much stronger in comparison to the gravitational forces. Okay. Next similarity I am going to discuss with you. Both the forces are very important fact. Both the forces, Coulombian force and gravitational force, both the forces, both the electric force and gravitational force, both the forces, electric force and gravitational force are central forces. What are these ones? I say these are central forces. So very important similarity. Once again, the objective type question may be asked on this concept. I have penned down here, I have noted down that both the forces are central force. What are central force? Actually, central force are those forces which acts along the line joining them. So you see, whether it is gravitational force or it is the Coulombian electric force, both act along the line which is joining them. Okay, that's why they are known as the central force. Okay, so what we have discussed, we have compared the Coulomb's law with gravitation law. In the beginning, I have write down the formula of these two, Coulombian and gravitational law. One property I have discussed here, gravitational force is of attraction, that is the difference, but electric force may be of repulsion or attraction. Both the laws, Coulomb's law and universal law of gravitation, they obey inverse square law. It means the force is inversely proportional to the square of the distance between them. Next one, electric force is very much stronger than the gravitational force. How much strong it is? It is 10 to the power 39 times stronger in comparison to the gravitational force. Both the forces are central forces. By central forces, I mean that this is the force which acts along the line joining the two bodies. Okay. When we have two charges, they apply the force on each other, but they act along the same line, the same manner. Two celestial bodies, they attract. Suppose this one, they attract each other, that is along the same line. That's why they are known as the central forces. And I hope that you have studied, I think you have understand the comparison. In comparison, there are some similarity and some dissimilarities also. That's an important question for the cbsc board examination that may be asked in 1 or 2 mark. Thank you very much for seeing my video. If you have any problem, then you can send your comments in comment box. In my next video, I will try to sort out your problem very soon. Okay, thank you very much.